This chapter focuses on embedding image content into the flow of an HTML document. The images are embedded in the inline content. We'll discuss web image formats, the image element, attributes for the image element, and adding an SVG to a page. SVG stands for Scalar Vector Graphics. It's important to know that you can't put just any image on a web page. It needs to be in one of the web-supported formats. And here's a list of formats that are appropriate for web pages: a PNG, JPEG, GIF, and an SVG. WebP is up and coming, not yet widely supported, so we're not going to talk about that one, but we'll focus on the top four. Images are bitmapped or in vector format. Bitmapped images are made up of a grid of colored pixels. So to store an image that's bitmapped, I'm storing the color of each one of these pixels. PNG, JPEG, GIF, and WebP are all examples of bitmap formats. The problem with bitmap formats, sometimes as you make the image bigger, you can lose the quality of the image. Vector images contain paths that are defined mathematically. An SVG is a vector format. The nice thing about vector images is as you scale them, they don't lose any quality. This is what an image element looks like. There's just a start tag, no closing tag. The source and alt attributes are required, right here, SRC and then alt, ALT. An image can be used for a PNG, a JPEG, GIF, and SVG. The image element tells the browser to make a server request for the image and display it in its place. When this HTML code right here is rendered in a browser, this tag right here is replaced with the image pizza, and you can see what it would look like down here below. The source attribute value is the location of the image file, so the URL of the image file. You would use the relative path name to point to the image on the server, and we talked about relative path names last chapter when we were talking about hyperlinks. The alt attribute provides alternative text for those who are not able to see it. It's required for every image element in order for the HTML to be valid. It's used by screen readers, search engines, and graphical browsers when the image fails to load. You'll be required to have the alt attribute when you submit your assignments. Points will be taken off if you do not use the alt attribute. Just a few alternative text tips. Alternative text should convey the same information and function as the image. If the image is purely decorative and shouldn't be read aloud, include the alt attribute with an empty value. Consider what the alt text would sound like when read aloud by a screen reader. Is it helpful or a hindrance? When an image is used as a link, the alt text serves as the linked text. Write what you'd want the link to say. Don't just describe the image. Avoid starting alt text with an image of or graphic of. The width and height attributes set the dimensions of the image on the page and the number of pixels. You don't have to have these attributes, but if you want your image to be a specific size, you will need to change. You can change the size of it with the width and height attributes. They help the browser maintain space for the image in the layout while the file loads. Don't use width and height attributes if you are sizing the image with style sheets or if the size changes in a responsive layout. If the attribute values do not match the dimensions of the image will resize and may be distorted or blurry. Sometimes what I do, if I want an image to be a certain width, I'll specify the width attribute, but I won't specify the height attribute. It will resize proportionally so my image doesn't look distorted. SVG images are unique. It is a vector format made up of shapes and paths. I've seen this with a lot of icons are in SVG format. Those shapes and paths are described in a text file using scalable vector graphic markup language. The elements in an SVG can be styled with CSS and scripted for interactivity. Because they are vector, SVGs can resize with no loss of quality. An example of where I've seen SVGs, a website might contain icons to social media. And usually those icons are in SVG format. So for instance, the Facebook icon. If you resize the Facebook icon, it still maintains the same good quality. You don't ever lose any quality when you resize it. Here's an example of an SVG. So you could just get an idea here. I'm not going to be asking you to create these or anything like that, but you can kind of see what this creates, this image here, and it creates a nice crisp image that can be resized and will always look the same. There are several ways to add an SVG image to a web page. You can do it with an image element, object element, or SVG element directly in your HTML. I'll just let you review those different ways as you read through the chapter. It's important to take a look at it. I will not be requiring you to create an SVG or use an SVG in our assignments. Next, we'll talk about responsive image markup. We'll talk about how responsive images work, high density displays, variable width images, art direction with the picture element, and alternative image types. Responsive image markup allows us to deliver images that are appropriate for the user's viewing environment. So we're talking about, are you viewing this on a computer? Are you viewing this image on a tablet? Are you viewing this image on a phone? How it works, you provide multiple image versions. You specify sizes and preferences with responsive image markup. The browser makes the final selection. So the browser chooses which image would be the best one for whatever environment you're viewing it in. Responsive image markup addresses 4 scenarios: sending larger images to higher density screens, sending a variety of image sizes for different screen sizes, sending alternately cropped images for small screens, providing alternative image formats with smaller file sizes to supporting browsers. Screens and images are made up of squares of colored light called pixels. On standard screens, so we're talking about your computer screen, or we're talking about the screen on your phone, the pixels in an image and CSS measurements map 1-to-1 with device pixels. And I'll show you a picture of this here in a minute. High-density displays fit 2 times, 3 times, or 4 times the number of device pixels in the same amount of space. High-density devices use a measurement called reference pixels for page layout. Images and CSS measurements map with a reference pixel grid, not the tiny device pixels. So let's take a quick look at this picture. If I have an image here, you can see I have an image with 9 pixels. And then if I have a device and the device has 9 pixels, it just maps 1-to-1. But if I have a high density device, in this case it's 2-to-1, so you can see this square here is now 2 squares with the height and 2 squares the width. And then over here you can see an example where it's 3-to-1. The one square is 3 squares in each direction here. These would be higher density displays. In order for images to look sharp and not blurry on high density displays, they need to map with the device pixels. For an example, an image that displays at 200 pixels wide in the layout, you would provide multiple versions. So you'd have the 200 pixel wide image for standard screens, But then you would provide a 400 pixel wide image for the 2 times high density screen, 600 pixel wide image for 3 times high density screens, and then an 800 pixel wide image for 4 times high density screens. Screens that have higher density have more pixels. You need to provide a picture that has more pixels, otherwise it will look blurry. The idea here is that you're providing multiple images depending on what your screen density is. The source set attribute in the image element lists alternative images based on pixel density, and it's specified with something called an X descriptor. The source attribute specifies the standard image, and right here you can see it's 200 pixels. We have alternate images, 400 pixels, 600 pixels, for devices based on 2 times the pixel density and 3 times the pixel density. The source set value is a comma-separated list of alternative image URLs followed by an X descriptor. A device with the standard screen density gets only the 200 pixel wide version. Higher densities get larger images. X descriptors tell the browser to make an image selection based on screen resolution only. Use X descriptors for images that stay the same pixel dimensions regardless of the screen size and layout changes. So this decision on which image to use is strictly based on the screen resolution of your device. It has nothing to do with the screen size or the layout. We just talked about picking an image based on the pixel density of your device. Now we're going to talk about picking an image based on the size of your screen. When images resize based on the size of the screen or browser window, such as in a responsive layout, use the source set attribute with a W descriptor and the sizes attribute to make a viewport-based selection. Here we have our image element. The source attribute is required and specifies the default image size. So this is our default image right here. The value of source set is a comma-separated list of images and W descriptors. And that's what we're talking about right here. The W descriptors list the actual image width in pixels. So this particular image is 480 pixels wide, this one's 960 pixels wide, and so forth. The sizes attribute specifies the size at which the image appears in the layout. In this example, it is 100% of the width of the browser. Here we have sizes equals 100 VW, that stands for viewport. So this picture is going to go across your entire browser like a banner. And depending on the size of your window, however many pixels wide it is, it will select whichever image would work best. If the image proportion changes based on the size of the viewport, use a media condition in the sizes attribute to test for the screen width and determine the image size. And this will make more sense in the next slide. This is what we're looking at right here. This is what we've added to this sizes attribute. If the viewport is 480 pixels or less, that's what we're saying here, the image fills 100% of the viewport width, 100% right there. So the image would display across the page. If the viewport is wider than 480 pixels but less than 960 pixels, the image appears at 70% of the viewport width. If the viewport is wider than 960 pixels, the image gets sized to exactly 240 pixels. Now that the browser knows the width of the viewport and how big the image will appear within it, it can select the most appropriate image from the source set list to download. Let's go ahead and go back and look at the previous slide. If the viewport was wider than 480 pixels but less than 960 pixels. Okay, this one was less than 480 pixels, so it took up 100% of the screen. This one was between 480 and 960, so it's taking up 70% of the screen. The viewport was set to 70%. This one It was greater than 960, and so it just said set the picture, I think it was to 240 pixels. The image just gets sized to exactly 240 pixels. So you can see how depending on how wide your layout is, how wide the screen is, you can adjust the viewport to be 100%, 70%, or not adjust the viewport at all and just say the image size is 240 pixels. So far, we've looked at image selection based on the resolution of the screen and the size of the viewport. In both of these scenarios, the content of the image does not change, it merely resizes. But sometimes resizing isn't enough. You might want to crop into important details of an image when it's displayed on a small screen. You might want to change or remove text from the image if it gets too small to be legible. Or you might want to provide both landscape and portrait versions of the same image for different layouts. In this example, you can see where the picture looks good on a desktop browser, but if we display it on a mobile device, you don't even hardly know what you're looking at when the focus of it was the dish right here. So we might want to provide a cropped version of the picture when it's on a smaller device. And this scenario is known as art direction-based selection. And you can accomplish this with the picture element. This is a wrapper element. It has no attributes. It's a wrapper for source and image elements. The image element is required and it goes last. But the source elements test for media conditions and provide alternate image options for each size. So we can see here where the example tells the browser that if the viewport is 1024 pixels wide or larger, use the large version of the ice cream cone image. If it's 760 pixels but smaller than 1024, then use the medium picture. And then finally, for viewports that are smaller than 760 pixels, go ahead and use the smaller version right here. And finally, let's talk about just having alternative image formats. New efficient image formats such as WebP, JPEG 2000, and JPEG XR are available but aren't supported by every browser. You can use the picture and source elements with the type attribute for image format-based selections. Browsers use the first image format they support and don't download the rest. So it would look through here. If it supports a WebP image, it would go ahead and load it. If not, go to the next one. And finally, we know that all browsers support a JPEG image, and so if the two more recent image formats don't work, it would select this last one. And finally, to wrap things up, picture, source set, and sizes are supported by all current browser versions. Every technique that we talked about includes a standard image element as a reliable fallback. And that wraps it up for images.